All right, folks. Today we're going to empirical formula. Since we already done uh, percent composition, which is related to empirical formula, we know how to calculate the molar mass. Because this is what we're going to use in the empirical formula. All right, let's get started.
When a new compound is formed or discovered, it is important to determine the chemical formula. Most often, this is done by taking a known amount of sample and decomposing or breaking down this compound into its component elements, or taking a known amount of sample and reacting it with oxygen to produce CO2 and H2O. The component elements, or CO2 and H2O, are then collected and weighed. The results of such analysis gives the mass of each element in the compound. This is used to determine the mass percent of each element in the compound. Knowing the mass percent of each element in the compound makes it possible to calculate its chemical formula.
All right, this is just introduction to empirical formula, which is the simplest ratio of the formula, the lowest, simplest ratio of the formula.
Empirical formula is the simplest chemical formula. The simplest formula gives only the ratios of atoms in a compound. Example, a 50-gram sample contains 13.28 grams of potassium, 17.68 grams of chromium, and 19.04 grams of oxygen.
All right, in this problem, you are going to need your periodic table and your calculator. We are given 13.328 grams of potassium, 17.68 grams of chromium, and 19.04 grams of oxygen. The total of these samples is 50 grams. So we're going to look at the amount of percentage of each one of them in that sample, and then we're going to look at the empirical formula.
Find the simplest formula. Analyze the problem. The mass is given. The mass of elements is also given. Make sure the sum of masses of all elements in the sample is equal to the mass of the sample. Element K. Mass 13.28. Molar mass 39.1. Moles 13.28 divided by 39.1 is equal to 0.3396 or 0.34.
All right, this is how to find the mole. We've done the mole before in the previous list. That is the mass given over the molar mass of that element. If you look at the question, the mass given in the question for potassium is 13.28. And the atomic mass of potassium is 39.1. So that you get your mole of that substance in the sample. And it gives you 0.3396. Using our significant figures, you have 0.34.
Element Cr. Mass 17.68. Molar mass 52.0. Moles 17.68 divided by 52.0 is equal to 0.34. Element O. Mass 19.04. Molar mass 16.0. Moles 19.04 divided by 16.0 is equal to 1.19.
Now, these are the moles for potassium, chromium, and oxygen. So the next thing to get our mole ratio is to look at the smallest mole out of all the three answers, 0.34, 0.34, 1.19. So once you get the smallest mole, you divide every mole you got by the smallest answer. So in this case, we're going to divide 0.34 by itself, which is because 0.34 is the least mole. It's another one for chromium is 0.34 as well. Then we have 1.19 divided by 0.34. That will give us our mole ratio. And the mole ratio is going to be the subscript for the empirical formula that we're looking for.
Select the smallest number of moles. Mole ratio, 0.34 divided by 0.34 is equal to 1.0. Mole ratio, 0.34 divided by 0.34 is equal to 1.0. Mole ratio, 1.19 divided by 0.34 is equal to 3.5. Remember, mole ratio is always a whole number.
Now, in this case, we have 1.0, 1.0, and 3.5. And you are not permitted to round up 3.5 to 4 because the mole ratio has to be a whole number. This is a special case. So any answer that you see that has 0.5 as one of the answers, you do what we call it, use factors. So you use a 2 to multiply it just to get rid of the 0.5. Maybe 0.5, 1.5, 2.5, 3.5, 4.5, 6.5, any answer that has 0.5. And remember, even if let's say one of the answers is 1.49. 1.49, if you change it, if you round it to one decimal point, it's going to be 1.5. So that is 1.5. But if you have 1.485 and you have to round up, you still have the same 1.5. But if you have 1.44, because the next number after 0.4 is less than 5, you ignore it. You don't round it up to 0.5 that we're looking for. So the answer is going to be 1 because the next number after 0.4 is less than 5. That is the rule.
Hence, multiply the mole ratio by 2.
So that will get rid of the 0.5, make it a whole number.
Hence, the simplest formula, or the empirical formula, is K2, Cr2, O7.
Remember, those are the subscripts. Those are the mole ratio. And the mole ratio becomes the subscript of each element that correspond to that. K is 2, Cr is 2, and O is 7. So the empirical formula is K2Cr2O7. All right, so let's go to interactive section.
Example: determine the empirical formula for a compound with mass composition 32.79% sodium, 13.02% aluminum, and 54.19% fluorine. Note, percent means consider 100 grams of the compound.
So in this case, 32.79% is the same thing as 32.79 grams of sodium. 13.02% is the same thing as 13.02 grams of aluminum. And 54.19% of fluorine is equivalent to 54.19 grams of chlorine. So you do the same thing with this as you did in the previous one.
Element Na. Mass 32.79.
All right. So molar mass is what? Check your periodic table for the molar mass or atomic mass. That's so the mole. How do you get your mole? Remember, the mole is the sample over the molar mass or atomic mass. So go ahead, make sure you pause the video so that you can solve them yourself before you go on with the solution. So at the end of it, you get 1.4, 0.5, 2.9. Remember I said if you have any one of them that has a 0.5, so because aluminum has 0.5, so everything must, all the three ratios must be multiplied. All the moles, so to say, must be multiplied by 2.
Thus, the empirical formula for the compound is
All right. What is the empirical formula if the ratio is 3 to sodium, 1 to aluminum, and 6 to fluorine? That will give you the empirical formula. All right, let's have one more example.
dimethylhydrazine has a molar mass of 60.1 grams per mole. It is made up of carbon, hydrogen, and nitrogen. The combustion of 2.858 grams of dimethylhydrazine and oxygen yields 4.190 grams of CO2 and 3.428 grams of H2O. What is the simplest formula for dimethylhydrazine?
All right, so I pause the video. I want you to try this out. Um, you have 4.19 grams of CO2 and 3.428 grams of H2O. What is, excuse me, what is the simplest formula for dimethylhydrazine?
All carbon in dimethylhydrazine is converted to CO2. In 44.0 grams of CO2, there are 12.0 grams of C. Therefore, in 4.190 grams of CO2, there are grams of C. Therefore, in 3.428 grams of H2O, there are grams of H. Therefore, the mass of N in 2.858 grams of dimethylhydrazine is equal to
All right, so once you have your final moles, you have to get your mole ratio. Remember, you have to look for the smallest mole and divide all the answers by the smallest mole to give you the mole ratio, which is equivalent to your subscripts.
Thus, the empirical formula for dimethylhydrazine is
All right, that's where we're going to stop today on empirical formula. See you again for the next period or for the next lesson.